Good afternoon, everyone. I'm the last guy that's standing between you and that very cold beer, so I'm going to try and keep it really, really short. Okay, my name is Raoul Diffouo. I'm going to be talking to you today about testing. I work for Prodigy Finance. Thank you. So if you haven't done that yet, please chat to Alex outside. I think she's got a riddle, and you could win yourself a good Raspberry Pi. Cool. It's funny, like all the talks from Prodigy Finance today are all about testing. I don't know if we spend too much time at Prodigy just writing tests. Maybe there's something there, but I can guarantee you we do write a lot of production code. My talk today is going to focus mainly on testing performance and how you can improve the speed of your test. But before we get started, I'd like to talk about a few reasons why I personally like testing. The first thing is it gives me the confidence when I'm building software to make changes, refactor code, and change the structure of my application without fearing that when I push the button to deploy it to production, things are going to break. The second thing that's very important for me is if I'm working on a legacy system, I need there to be test because I want to be able to, write some new features and push them out again without fearing that I'm breaking something. You don't want to get on that job and then first feature to production, you break something and then you get fired, right? We don't want that to happen. I think one of the big problems though, especially with legacy system, is that over time you get a lot of people that come and work on the same project. And so things like your test start to grow, they start to take a lot more time to build. In our case, in this one particular system, we're sitting at about 21 minutes to run our entire specs. Now, if you add to that the time it takes to build the image on your continuous integration system, we were roughly at around 30 minutes to run everything. And that's a lot of time to wait before you can push code out to production. And so most of my days looked something like this. You run RSpec and then you wait, or you start to have a lot more coffee chats with your colleague, but I mean, you don't get paid to do that all the time, right? You want to actually build something. And so we needed to find a solution to this. The first thing that we attempted is this very nice gem called parallel test, which allows you to split your test across multiple cores on your computers, and that can significantly increase the speed of your test. But the problem with this is really just a band-aid to your problem, right? Because down the line you add more tests to your test suite, this will continuously grow and grow and grow. So this wasn't really a solution for us. So we needed to find a better, go to the core of the problem and solve it. And so that's what this talk is about. I'd like to cover some of the things that we did on this particular project to bring the time it took to build our test a little bit down. The first thing that we did was look at our spec configuration. So this is a Rails application, and we use RSpec to write all our tests. The second point was around how we interacted with the database in our test. And then I've got a few other points that I'd like to touch on. So first, let's talk about RSpec configuration. I don't know how many of you are still working on a Rails 4, hopefully not many. Hopefully you've migrated to Rails 5. I feel for you, man. Anyway, typically what you end up with in old Rails application is that you have a single spec helper configuration if you're familiar with RSpec. So this is where you set up all the tooling that you need in order to run your specs, right? But this is fine and all, but if you remember that slide that I had before, this adds up to the time it takes to actually start your test and run your test. So one thing that was introduced since RSpec 3 is that you have the ability now when you're setting up RSpec on your project to automatically generate two configurations file for you. The first one is the spec helper file, which contains the bare minimum configuration that you need to run your test. So this is any kind of test. If you're writing tests for just a library that doesn't rely on Rails, you will need this. The second file that gets generated for you is the Rails helper. And thus you really want this in order to test things like your controller specs, your feature spec or model specs. Now why is this important is that if you practicing TDD, when you're running your test, you want to be able to make changes to your code and instantly get feedback from your test on whether or not the code that you introduced made a difference. But when you have that single file that we saw earlier on, if you look here, we can see that we have about 8 seconds that it takes to load the entire stack before you run your test. Now, if you think about the scenario where you're writing tests and then you want to check if it works, 8 seconds is a long time to wait for to see the feedback for your actual test. Okay. So if you're still using a single file, do consider splitting them into two. The other benefit with this is that if you want to write tests that only test your models, for instance, you don't need to load the entire Rails stack to test your models. All you need really is active record. So you can write a different configuration file that only loads active record for the purpose of testing interactions with your models. Cool. So that's for some of the bits that we needed to change in our configuration files. I think the big amount of time that we spent was really around looking at how we're interacting with our database inside of our test. How do we create data and like what's the impact on that on our test. So I think one of the big things that we spend time on is really learning and understanding what cleaning strategies do you have around, because when you're writing your test, you create a bunch of data in your database, and you want to make sure that when you you run the next example, that you have a clean slate in your database before you run that, right? And so there are a number of ways you can sort of manage that. So these are the standard ways to do that. So you can use either transaction mode, you can use truncation or deletion. Now you've got a very nice gem that provides you an easy way to switch between those configuration in RSpec environment, and the gem is called Database Cleaner. I'm pretty sure most of you are familiar with the gem. But before we go down to that, I wanted to quickly explain the difference between the two key strategies that are used by most people, which is the transaction and the truncation strategy. So a transaction in the context of a database is a logical unit that is independently executed for data retrieval or updates. In the context of a relational database, a database transaction must be atomic, consistent, isolated, and durable. What all this means is that, especially I'm going to focus on the atomicity of this, a transaction are completed by either a commit statement to your SQL DB or rollback statement. Let's have a look at this in the context of a test when you decide to clean with transactions. What you can see on the left here, so this is your testing framework, and then you have an example that you've written. And that example, when you start running it, it will begin a transaction. And let's say in the setup part of that test, you want to create some data. So the first thing that you do is that you insert some data that gets written into your database, quote unquote. And then your system under test will try and do something. And during that process, it tries to read from the database. Now, in the context of a transaction, for instance, what happens at the end of all these processes is that everything that was either inserted or deleted during that process gets rolled back. Okay? So let's keep that in mind when we talk about some pros and cons of dealing with transactions as a cleaning strategy. The first thing is it's fast. The reason why it's fast to use transaction in dealing with database is because you really don't write to the database. So there's no interaction with the disk at this point in time. Everything is kept in memory. And so it's easy to quickly roll back those changes without having to commit them to your DB. So that's the one aspect that makes it fast to use transactions. A few things that you need to watch for, though, when you decide to go with transaction as a strategy is that whatever you create in your test, whatever you create as a seed to your test suite will remain in the database. So think about seed file that you have that automatically populate your database before you even start running any of your examples. All that data will remain in the database. And the reason why you want to do that is that sometimes in your system you have a piece of information that are static that will not change throughout the life cycle of your application. So you want to create them beforehand and keep them there so that your test can make use of them, right? In between example, they're not going to be deleted, they will remain there. Only the things that you create within an example will get rolled back. You want to watch out for specs that are dependent on table IDs. When you're working with transactions, the IDs of your object do not reset. The auto-incrementation of those IDs do not reset. So if you have a test that wants to check if the ID of this object is equal to 1, you're going to start to see weird things happening in your test where a test that was working before stops working because now you're looking for this thing to have a specific ID, but then because other tests ran before, it has a different ID now. When you have tests that involve multiple DB connections, this can be a case for feature specs, where in your setup phase, you create data in your database in a separate thread, and then your browser in your test tries to access that data. But now keep in mind the diagram that we had before where we start a transaction, that transaction happens in a single thread. Now your browser is trying to access data on a separate thread, and you start to see failure because you can't, like that thread doesn't have access to the data that was kept in memory for that when you created the data. And in order to solve this kind of problem, we often resort to using truncation as a strategy for cleaning the database because in the truncation mode, what happens is that all your data, regardless of when you create it, will actually be physically written on your database. And so any connections, any thread that needs access to that data will be able to get access to it. Okay? So again, Database Cleaner gives you an easy way to switch between that for those scenarios. All you need to do in your Rails configuration is to add this one line here and set the strategy to truncation. And so before every test is executed, it will clear your database, and at the end of it, it will also delete everything that you created. So one advantage is that it wipes out your DB in between specs. So if you want to be 100% sure that everything that you created in your example was deleted and you have a clean slate, this will probably work for you. But it will also help you with tests that rely on multiple DB connections, right? But the drawback of that is it's incredibly slow because now we're writing to the database, and then when we want to delete, we're also interacting with the database directly, which makes things super, super slow. Now imagine having to set this strategy for a test suite where you have about 2,000 specs. That adds up quite a lot. And so what we did in this case is that we went from a test suite that was primarily relying on truncation as a strategy to clear the database back to transaction because we needed that speed. And all of a sudden you find yourself in a position where a lot of tests start to fail intermittently on your CI build. Because now in the transaction, everything that you create will get deleted. And so in some of your tests, you start to expect that you have a certain state, but it's not the case anymore. Now you need to go back in your test and start to look at what is actually going wrong. Now you spend afternoons trying to rerun your build about 7 times. Now you have a CI build that takes about 15 to 20 minutes to run. You have to do that 7 times every time now. That time adds up a lot. We're not talking about 30 minutes anymore, but a lot more. And as Aaron points out, flaky tests are worse than useless tests. So you want to make sure that you identify the cause of these issues as soon as possible and you fix them. In our case, most of the time it was because of one of the gotchas that I mentioned earlier on around writing tests that rely on specific IDs, you validating those IDs, and so we had to fix that. Another common example that we had is a scenario like this one, where we have this migration file here where we're creating a feature flag. Now in this context, we're going to assume that we have no validation on this table for the name. So we create one feature flag here with this migration, and then we write a spec that tries to make use of that migration. Now in this example here, look at the before each block. We're trying to find a feature flag with this name, and then we updated state, right? Now, in this section here, we have a before all that executes before all your examples, and we recreate that feature flag again. Now, in the context of truncation, this works fine, because regardless of what we had in the database before, we have a clean slate, and then everything is recreated, so it's not going to cause any problem. But now you have the same spec and you switch back to transaction as a mechanism to clean your database. Everything starts to break because now you've got 2 records in your database, the one that was created with your DB migration and this one that was created in a before all block for your feature flag, right? And so your tests are trying to read one of those records from the database and then they try to update them. And you're never sure, like in one of the example, it might pick the correct one and run the test and it passes. And in another example, it picks the wrong one, which was not updated, and your test starts to fail. So you start to see a lot of things like this in your test. Now you need to go back and track all these specs and make sure that you fix them accordingly. And this was a very intense exercise that we had to do. One thing that I need to note though is that when you switch to transaction, before alls are not bound to transaction. So everything that you create with a before all block will remain in the database at the end of your spec. It will not get removed after that. And so you find yourself in a position where you just finish running your test for the first time, you start a new block, and immediately one of the specs fails randomly because of things like this. Well, Database Cleaner itself is a gem that just gives you the ease of changing between these configurations. If you decide that you actually want to stick to transaction, which is what we did, you might not need to use Database Cleaner at all in your project. And so we got rid of that. Rails actually provides you a way to clean your DB using transactions with a feature called transactional fixtures. This has nothing to do with the fixtures that you create for your test. It's just providing you with the same behavior that the transaction strategy of Database Cleaner gives you. And this has been in Rails for quite a while, and I only found out about this when I was sort of like going through this exercise. The way you want to set this up is in your spec configuration, you just configure the use transactional fixture to true, and then you have everything going. Now, don't do this and keep Database Cleaner in your configuration and try to run a truncation at the same time, because then what happens is the one group of specs will try to run with transaction, and at the same time it tries to use truncation, and it gets there and then it hangs. Okay, we had that issue as well at some point. Also, as of Rails 5.1, we have better support for multiple DB connection, which means you should actually be okay using transactions when you're dealing with database cleaning, as long as you know exactly what you're doing and what you need to watch for. Rails also had a little bit of a fix to ensure that test thread that can share the same DB connection, which will address the issue that I mentioned earlier on, where you have one thread where you created the data in your DB, and the second thread from your browser that's trying to access the data. So that problem is taken care of. So after this exercise, we went down from 21 minutes to 8 minutes on our unit specs. You'll note that we have a few tests here. We had about 2,000 before, and now we're down to 1,700. That's because we split our tests in two groups. At this point in time, we still we needed to have the ability to run a portion of our test using the truncation mode because we needed to move on and continuously improve on those tests. So over time, we sort of got back and take one text, fix the issues with that test, and move that back to this group. And so the second group that we called integration spec was configured to use truncation, and this group was running at about 4 minutes, which was okay. And if you're running this in your CI setup in parallel, it literally takes you 8 minutes now to run the entire thing. Okay. A few things to note. Remember the example earlier on where we created data in our migration? Well, there were a lot more instances like that where we found ourselves debugging for hours. Why is this test failing? Turns out it's because in our migrations, we had things like this where we were creating a bunch of data. And because we're new developers in the team, we're not necessarily aware of these kind of things. And so you write your test expecting your DB to be in a certain state, but it's not. And so your test starts to fail because of that. So we opted to stop doing those kind of things. Don't use DB migrations to create data. Rather revert to data seed. So use your seeds to create them. Again, interacting with the database is very expensive. It takes a lot of time. So make sure that you only create data that you need in your database. If you don't need something, don't create it. We had a lot of integration spec that required us to have certain data in the database. And in some instances, you look at the example, we've created a bunch of data in there, but we only need one record in the DB to test that the functionality works. Why did we create all of that? It's time wasted. So cut down on all of that and make sure that you only create stuff you need. If you're using factories with factory bot, you have to watch out for a few things. Factory bot gives you the ability to create factories with the create method, and what I found was this was one of the methods that was highly used in our code base, in our test. What this does is that it returns your model instance and saves that into the DB, which is fine if you really need to access that record from your database in that test. But in cases where you actually need a representation of that object in memory, you don't need to use create, rather default to build, which will give you an in-memory representation of that object, and you can use that to test whatever you need to validate in your test. So you save time here by not writing to the database in your test and rather having an in-memory copy of that. If you happen to have tests that rely on some active record models, so you can use build stub, and it will give you, it will stub up some DB interaction method like saving and updating and so on. Cool, let's wrap this up. So, this morning I ran our specs again, and we're down to about 2 minutes on that integration specs. So we kept going with the improvements of the specs over time. And actually, I think I skipped one slide. So this is our unit specs. It's down to 5 minutes now, all in all. And we're back to about 2,000 specs as we had originally, because we slowly migrated all the specs that were broken on the other side back to the unit specs. We can have some celebration, right? Now I don't need to take too much breaks with my colleagues, and we can actually spend time doing the things we were hired for. Cool. These are my opinions from what I've learned from this. If you are going to set up your testing, just prefer using transaction over truncation, because really you don't need it. Even if you're doing tests with Cucumber, for instance, we've set up a project recently with Cucumber, and we were able to get away with just transactional fixtures. All of it just works. You have to avoid excessive calls to your database because it takes a lot of time to read and write to it. Only create data that you need in your test. Don't use DB migrations for seeding your database because this will come biting you afterwards. A few resources that help us while we're going through this. Please read two great books, Rails Test Prescription, which will go over some philosophies of how to write tests for RSpec. Effective Testing with RSpec 3 will just give you some pointers on how to better make use of RSpec. And the last link here is more about transactional fixture, which is a blog that I went through as we were looking into this, which really explained how it all works. So feel free to look into that. On that note, happy testing to you all, and thank you.